All right, good morning, guys. This is division properties of exponents, and the objectives is to divide powers with the same base and to raise a quotient to a power. The main difference today is going to be the look of it. We're going to have something like x to the fifth over, let's just say x squared. All right, so you guys know that x to the fifth power, there's actually 5 x's on the top. All right, and then x squared, there's actually 2 x's on the bottom. Now, if you have the same thing on top as you do on the bottom, they would cancel out, so that equal a 1 basically, so you don't have to put it. And so with that. So you're left with x to the third power. So if you look at the original problem and then you look at the final answer, some of you might be thinking that there's a shortcut to this, and there is. As long as you take the top exponent, subtract the bottom exponent, you'll be left with the final answer. So just make sure your final answer is considered to be in the numerator. So for example here, this x to the third power, there's nothing left on bottom. You could put a 1 if you wanted to, but you don't have to. So your final answer would just be x to the third power. Okay, and there's some variations of it here. We have 2 to the 6 over 2 to the second. So to do this problem, you'd write it as taking 6, subtracting 2. 6 subtract 2 would give you 4, 2 to the fourth power, and then that would final answer would be 16 for that one. Okay, a little bit different for this one. X to the fourth over x to the seventh. All right, so this part is really important. You always take your numerator, whatever's in the numerator, subtract the denominator. So start with the 4, take away 7. 4 take away 7 is going to give you x to the negative 3 power. You can have a negative exponent, so then you move it to the bottom, which would be x to the third. Now, I'm hoping that some people are thinking that, well, maybe you could skip some steps and just put your answer on the bottom right away rather than rewrite it twice, and that's true. There's a couple of different ways actually to teach this. So the first method here is done, but let's say you want to use a different method and do this instead. Well, since you know x to the seventh is the bigger one anyway, why not just move x to the negative 4 to the bottom, and then you still have x7. Okay, so you move this one down here, and then 1 over, and then now you add them. We learned that earlier. If you have the same base, you just add them, and then you get x to the third power. So it's another way of doing the exact same thing. As long as you're getting the right answer, either way is correct. It really doesn't make a difference. Okay, and the last one here, we got s to the 3/4 over s to the 1/2. So we're going to be taking the top one, and that's the method I'm going to be using throughout the lesson today. I'm going to be taking the top one, subtracting the bottom one, and placing my answer on the top, and then deciding if I should be moving it or not. All right, this is going to give me, let's see here, that would be 1/4 as an answer. All right, so this would be the first couple problems for your notes. So what is the simplified form of each expression? Then we got the a and the b. For the first one, you're going to be taking the top one, 5 over 2, subtracting the bottom number, which is 2. So 5 over 2 is the same thing as 2.5. 2.5 minus 2 is just 1/2. All right, so for the first one, we'll be taking 2, take away 5. And then for the n value, we'll be taking 4, take away 3. Take away 3. Now you notice how I'm putting everything on the top, and then later on I'll decide if I want to move it up or down. That's going to give me m to the negative 3 and n to the first power. So I can see that the m is going to move and the n is going to stay. So n to the first stays on top. M to now the positive 3 move to the bottom, and that is the correct answer. All right, so for letter A, you'd be taking 3/4 minus 1/2. I think we actually did one a little earlier. 3/4 minus 1/2, our final answer would be y to the 1/4. 7.5 is the same thing as 3.5. So if you take 7.5, take away, 3.5 take away 3, you'd be left with d to the 1/2 on top. Okay, here's a good one. So we'd have k 6 minus 1, j 2 minus 5. All right, so we got k to the 5th. That's going to stay on top. And like right now, I'm thinking about skipping steps. If I take 2, take away 5, I get negative 3, right? So I might as well move that to the bottom right away and get positive 3. For letter D, I'd have, and sometimes it's good just to write them out, just to make sure you keep everything straight in your head. We got negative 3 minus 5. And that's a little tricky there. So we got negative 3, subtract 5. Take the top, subtract the bottom. Then we got B, 7, take away 2. So a negative 3, subtract 5 is negative 8. Might as well put that on the bottom right away. 8 to the positive 8. And then our B value is 7 minus 2, which is 5. Okay, let me make some space for letter E here. E is a good one. So of all the problems up here, letter E is what I'd want you to know the most, prepping you for Algebra 2. Okay, so first the X's. Take the top one, subtract the bottom one. 4, take away 4. The Y, take the top one, subtract the bottom one. Now, I like the letter Y here. What you end up getting is you'll take negative 1, subtract a negative 5. And I think you know where I'm going with on this one here. The Z number would be 8, take away 1. All right, so X to the 0, Y to the, so 2 negatives equal positive. Negative 1 plus 5 is 4. And 8 take away 1 is 7. All right, anything to the 0 power is 1. Y to the 4th. Z to the 7th. If you want to, leave the 1 off. And there's the final answer. Okay, this is a nice to know. I'm going to show you how to do one of these, but it's not a big one as far as the lesson's concerned and the next test, but I do need just to show you how to do it here. The population density described the number of people per unit area. During 1 year, the population of Angola was 1.21 times 10 to the 7th people. The area of Angola is 4.81 times 10 to the 5th miles squared. What is the population density? All right, so what they're getting at here is the whole lesson we're dealing with division. So what we're going to be doing is we're going to be finding the population density by taking the two numbers and dividing them out. Okay. Now this right here, you literally just type in your calculator. Take 1.21 divided by 4.81, and you'd get 0.252. Times 10 to the, and you just learned how to handle this part. If you have the same base of 10, subtract your exponent. 7 subtract 5 gives you 2. All right, in scientific notation, you can only have one integer out front. So move the decimal to the right one spot, giving you 2.52 times 10 to the, and if you moved it one spot to the right, you would subtract 1 from your exponent and get to the first one. Okay, and this is the last concept, guys. It's raising a quotient to a power, which is going to look really similar to what we did last lesson. So you see this big group, right? This big group is raised to the third power, and the rest of this problem is actually just kind of fluff. They're giving you some options for answers, but let's just get to the right answer and ignore everything they're doing there. Okay, everything in parentheses gets raised to the third power. So z to the 2/3 goes in parentheses, and 5 goes in parentheses. We distribute the 3 to both of them, so put a little 3 there and a little 3 there. Put a 1 on bottom. You can cross cancel the 3's. You'd have z to the 2 power on top. On the bottom, you'd have 5 raised to the third power would be 125, and there's your correct answer right there. And I think there's a couple more on this next page here. Yeah, there we go. So this would be another good one for your notes here. Everything gets separated. The 2, the x6, the y4. Separate everything and then distribute the negative 3. Oop, I got to put the 4, sorry. I got to put the 4 in the, with the y. y4, raise that to the negative 3 power. There we go. Okay, so the negative 3 was distributed to all. Let's multiply them and see what we get. Now, for the top one here, or should I say for the first one, there's not much to do on this one right here, except really move it to the bottom because it has a negative exponent, and then 2 times 2 times 2 is 8. The x is to the negative 18 power. If you're thinking about moving it to the bottom, you would be correct. And then we got y to the negative 12. And that also is going to get moved. So our final answer for this one, the 8 stays right where it's at on the bottom. The y moves up, and the x moves down. Right here, just another quick example here. Everything gets separated. The A gets separated out. The 5, the B, absolutely everything gets separated, and it's to the negative 2 power. Now, usually what happens with that negative power like that is a lot of things just get moved around like crazy. And for example, the A is going to get moved to the bottom because it changes to a positive 2. The 5 to the negative 2 power, that's going to get moved up, and 5 times 5 is 25. And the B is also going to get moved up, and there's the correct answer. Okay, and this is what the homework assignment is going to look like. For the first one, you'll be taking 3, take away 10, get negative 7, so you move that to the bottom, so 1 over y to the 7. And another really good one just to talk about here is number 4, guys. Separate everything out. We got the 3, x squared, the 5, the y4. Everything gets a negative 4 power. All right. Okay, so 3 to the negative 4 power, that gets moved to the bottom. 3 times itself 4 times is 81. The 5 to the negative 4 power, I'm sorry, I'm working this one right now. I'm just working the numbers first. Would be 625 moved to the top. The x. And you take 2 times negative 4, you get negative 8 on the top. But if you want to make it into a positive 8, you'd have moved it to the bottom. And the y, so you're taking 4 times negative 4. That's y to the negative 16 on the bottom. So if you want to make it into a positive 16, you can move it to the top. And there's your correct answer. All right, guys, that's everything, and good luck.